Hello, everyone. Good morning, good afternoon, good evening, depending on whichever time zone you are joining us from. Thank you so much for joining the 39th meetup of Gaggle Days Meetup Delhi NCR. We are back again with an online meetup after we conducted our offline meetup in August at Evaluserve Gurgaon office. So today we would be having a very interesting topic around deep active learning by Gyanendra. He is a Kaggle competition expert, so we are quite excited about the topic, and I'm hopeful that we can get to learn a lot from this session. And feel free to drop your questions during the session, and we would be happy to pick up any question. Over to you, Gyanendra.
Hi everyone, I'm Gyanendra and I'm Kaggle competition expert right now. And except that, I I do some research kind of thing. Right now, my main research was about active learning, so I choose this topic to present. So, um, and I'm doing my masters, integrated masters from IIT ISM Dhanbad from, and this is my final year. Yeah. So let's talk about deep active learning. There are we know about three types of learning before, like supervised, unsupervised, semi-supervised. Supervised is like we have the input output pair, like we have input x and out what is the label of that input output y. Unsupervised, we have only inputs of x and we learn, uh, train the model or anything on without only with supervised. We learn from both, like we have unsupervised data also, we have supervised data also. So in semi supervised we learn from both. In the active learning setup, then what we do is like there will be human in the loop. Like in the first we don't have we have hundreds millions of unsupervised data. I mean, they don't contain any output label, but in the
Gyanendra, you are not audible. If you can check with your microphone once.
model will select from the on level data some x days and will give to the human, and human will annotate it and will again train the model. So why we do this type of setup? The in this this is in the supervised, why what we do, we have the we'll try to build a classification boundary always by seeing the data. In the active learning, what we want to do, we want to choose the hard samples, like which, if we'll predict for that hard samples, will predict for others. Like if we choose these 5 point, we can build a classification, and easily it can be the overall classification. So that is the motive, like with the minimization of labeling cost, we will learn a model. Why it necessary? Thing is, let's say we want ASR model, audio speech recognition. This is there is very much labeling cost behind this. We can get audio from millions of audio, but to label it, will give we have to give some humans oracle team to label it, and this has the much cost of it. So we want to select some of the data which will which will be the representative of so much on level data. By that we can learn a decision boundary very quickly with less less data points. That's the motivation behind active learning. So there are two type of fundamental area, like uncertainty and representativeness. So let's suppose here in this figure, um, in the bottom low, so if we'll the hard examples are which are close to the decision boundary. So if we'll classify those hard examples, then we can classify every um, e- we can classify every data points. And and that is called uncertainty, like we want to choose the hard samples for those. And representativeness means, let's say we have some of we want diversity in whatever we choose. We want diversity in those samples. Like if there are five type of classes in our data set, and only hard examples, if we'll say to choose the hard examples, model maybe select only class 1 class 2, and so that it won't have diversity enough, that it should have choose also all classes. That's called representativeness, and also called diversity. So that we want model to choose the hard samples, and it should be the diversified between all the data points whatever we choose. Let's let's talk about some uncertainty measure, like how we can choose those samples. So the key motivation behind uncertainty sampling is we'll find where the models are most uncertain. Let's talk about let's say if model model is on model is predicting, there are two classes binary setting. Model is predicting 0.9 to class 0 and 1 to 0.1. And for another setting, and for another example, it's predicting 0.45 0.55. In here there is if 0.45 0.55 means it has more entropy, and model tries to confusing bit for this sample. If it will correctly classifying 0.9 and 0.1, not correctly, like if it is giving more probability to the 0.9 and less probability to 0.1, that means it has certain that it belongs to one classes. But 0.45 and 0.55 means model is confusing between two classes. So we will choose those sample which are where model is confusing. That is in uncertainty sampling. Like what we will do, we'll predict the probability score, like we have the softmax score, and then we'll calculate the entropy. uh, and that will will sort it out, and we'll choose top k samples for our next. We'll choose top k samples and give it to the Oracle team, and it will label it and will include in our training set. Then we'll train again, and we'll get a next iteration model, and we'll choose again. And next method, query by committee. Let's say we train 5 models, and um, for one sample each model predict class 1, and uh, and in the for second example, 3 model predict class 1 and 2 models predict class 0. That means here also there is a confusing, and this is also uncertain. So that method called query by committee will choose for which samples the models are confusing. Here on certainty sampling there is one model, and query by committee there are five models which are confusing. uh, that we talked about entropy. We can do entropy, like we have the probability of what, how much is probability to belong to y class, and we'll take log of that probability. So we'll sort it and we'll choose the top k1 at top one confidence. So let's suppose um, we have 10 classes, and the first class model is predicting 0.5, and second class 0.3, and other class remaining 0.1, 0.05. Sum of total will sum of 1. So what we'll take, will take um, distance between first probability and second probability. That will be our uncertainty score. Then we'll sort it out again and choose the samples. A top one confidence is how it is the probability of um, what is the probability of lower top one confidence. That means it is more uncertain. And here is margin that we talked about now, like between first and second candidate. That means it is more uncertain. So these are some of the method that we use for uncertainty sampling. Query by committee, like we run multiple models, and we'll see the how much disagreement there. Then uh, like we do for a random forest or gradient boosting algorithm, we run multiple decision tree and start ensembling it. But here here we'll do, we'll see how much on how much disagreement between this thousand of decision tree, and choose which sample is more of uh, confusing the model, and choose that choose that sample to label it. And this we talked about uncertainty. Now let's cover representativeness or diversity. um, how can we classify the examples as being similar to many others? In simple feature vectors, high overlap in vectors, but like let's suppose this is will only choose uncertain, like when model is confusing. Here you can see that uh, m- model is choosing model is choosing those samples which are hard enough, but not choosing everywhere where is the our domain. So so this approach is called core set approach. And there are most of the papers or research right now on the uncertainty approach, but some approach are based on diversity. But we should also, in the real world scenario, there is much problem of diversity. So um, we should allow some of the diversity samples to our labeling sample, so that all the data, whatever we have now training data, it will be representative of all the classes in the on level set, or in the sample space, of the whole data. This all method uh, is for machine learning. Let's talk about some active learning or deep learning. So for deep neural network and are really good at telling when they are not sure. That is the main problem behind this. So deep when you train this fast type of model, they try to be overconfident. And if they're overconfident, and if they're telling false also, they're overconfident. that's why there is a problem. Let's suppose uh, let's suppose we have one class that will predicting 0.9, but actual level is 0.9 for but actual level is 0. So that means the model is now falsely confident about something else. So that's how, but here we can we do this. The model don't have confusing here, but so we can't choose the sample, but this sample should be choose because this is the hard samples. If we choose this one, then our model will learn to classify good classify region. So that is our motivation for how we'll choose something from for deep learning model. And deep learning and why we do this, like deep learning model are computationally heavy, and 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 we can if we have enough representative of data, enough data which represent the whole whole sample, then we can train a deep learning model so that it will have less cost of training on the whole data. So that's the motivation behind why we are doing active learning for deep learning. Here the problem is acquisition function we saw so far, like tell us how to select the single best image or a text, not a batch of images. Like we'll pass one image and we'll see if we'll see if it is what is the uncertain of that, will include to our data set, and again we will see train a new model and do that iteration again. But for deep learning, if we'll every time, let's suppose we have 200 sample at first, and every time we are uh, getting every time we are taking one sample and adding it, so we have to train 1,000 times more. So there should be a technique which choose batch of samples or batch of images to select from on level pool. Let's suppose we have now 200 data, and second iteration, let's take another 200 directly and add it to our training set, not one. So that's the problem. uh, there is a method deep Bayesian active learning with image data. Um, the idea behind Bayesian neural network give better on certain images. Like um, it's not really overconfident in those. So in Bayesian neural network, every parameter of the model is sampled from a distribution. Then when doing inference, we will integrate over all the possible parameter. So we are using an ensemble of infinite different methods to compute the output. Like we talked in the query by committee, we have different type of models, and we'll see if they are confusing to predict the actual level of soil. If if they are confusing, then it should be in our data set. In the deep learning, we can train five different model and choose if it is confusing. So in the deep Bayesian active learning, what it does, like it for every parameter, it's sampled from a distribution. So for training, it does that. So when inferencing, will integrate over all the possible parameter, and we can choose infinite model to compute the output and see that if it is confusing or not. And let's some talk about uh, some of the strategies for text. Like we talked about images, and like image or image are, there are more of research in the image field active learning, less in text. Let's talk about that. How can we do text level active learning? In the test classification, so there are mainly three type of class. Like test classification will give some sentence and will predict the classes. Let's suppose the classes is binary. I like pictures and will create full of predict. This is the positive. And tagging is will predict what is the pronoun, verb, noun, the tag of that word or sentence. And sequence to sequence tagging will translate or um, uh, like I like pictures to some Japanese code or translating framework. This is sequence to sequence. And so sequence at token level, how to do like for sequence learning and sequence to sequence, we can do at different levels. Like that for I, this will be pronoun, and like it will be verb, pictures will be noun, and token level will give will say the human to only label this like, and sequence to sequence level will say the human to label all the words. Token level makes it possible to adjust difficult parts of sentence. If we let's suppose in the I let's highlight pictures, it will say human to annotate it. It will take more time than it will say only to label the like. So it will be more of time saving in the token level, but it requires strategies to learn from individual examples. Um, there are some of the uncertainty like we talked about uncertainty and diversity. Here are there is also top one confidence margin and sequence level entity. Sequence level entity will be um, le- for generation. Let's suppose we are generating um, from Hindi to English, and we generate five for one sentence. We'll gi- give the screenshots and everything, and it generate top five confident samples. And now for each sample, we'll calculate this essential and just sum about that. That will be our trivial sequence to sequence level entry. And token level, how can we? The main thing will be how can we train on partial data. Uh, like here, what we will do, like in the sequence to sequence, this word, this prediction word is depends upon I like and pronoun. But let's change this example. Like it will be Hindi, and pronoun word will be some English sequence to sequence. So it will this second prediction depends upon before step prediction and what is the input. But in token level, we don't have a label for previous step, label for previous step. So what we do here, like we'll treat each prediction as independent. Like we'll directly map like to verb. Uh, so it will have structured prediction method. We can like we have like to verb, and let's say sentence is long. We have another one for which we have the tag. So you predict for without depending from before step or after step. We'll only predict for each step independently depending upon other step. And now we'll get some uncertainty score, and then we'll sum about those. That is our marginalization. And here we can do accumulate all the uncertainty across token instances, and then we'll select the representative of that token. So in the sequence level, back uh, what is the sequence level and phrase level. Example, back translation like you, like if given, um, let's suppose our task is from changing for translating Hindi to English. We train the model, and we'll for each sample what we'll do, given a English uh, uh, given a English caption, what is the probability of what is the probability of getting the Hindi sample? That will be our back translation like you. For phrase level most frequent uncovered phrase. There is some other active learning method that we can do, like cross-lingual. There are a cross-lingual or multilingual. We can think of something like, if uh, there are samples in Hindi, English, Japanese, German, and we'll choose if it is in the first phase model is good about English, but it is bad on other lingual data point. We can choose a more high priority to those languages. So there will be a idea behind in the cross-lingual learning. Oh, so what will be the human effort and active learning? So in simulation, it's common sense to access active learning based on word sentence annotated. But in, like, we can see in I like pitches, if we'll give the word like and we'll map it to the verb, the human will map to the verb. Actually, but human will see the whole sentence and then say that like is here verb. So it actually, it is more hard problem than say that to give whole bunch of level, and it has more time. If human, there will be human bias in there. If for some time this is noun and next time it will comes to as noun, but comes to as verb, but as human label it as like to noun, next time they will also label it noun, so there will be error behind that. So there will be problem of human bias in this type of token level learning. We can cost of active learning. We can say, let's suppose uh, we have m- m- let's suppose we have um, let's suppose we have image data and audio data as well, and or text data as well. So if for we have image, audio, and text, so what will be the cost of label the image? It will be less than text, and it will be less than, so hard to label the audio data is more harder than label the text data, and that will be more harder than label the image data, because in the image data you will see and label it what is the class. For text, it has to human should read it completely, then label it, and in the in the audio data, human should hear it and then label it. So in the multimodal setting, we can think of, if we have both image, text, and audio, and right now, if we will think of like dynamic is something like dynamic programming type of thing, where we'll choose what is the best number of image only to label, what is the best number of audio only to label, what is the best number of only text to label. By that, we can consider the cost to be minimized and get samples from by active learning method and label it, then train it. So it will be cost sensitive. Uh, so uh, let's suppose we have we label it some one data set, and there will be a problem like active learning annotations are often with one model, may not transfer well to other model. That means we trained one model right now and is choosing some hard samples, and we'll train another model another time, another type of model, and those hard samples are easy for this model. So whatever you annotate for this model from the first model can't be a good representative for the second model. So we can't reuse those annotation for the second model. So, so that's why active learning is little bit hard to select which type model we want first, then we will proceed. And there are some of the key aspect of now it is active learning we talk about, like some papers try right now diversity. That first we talk diversity samples, how they mentions diversity, um, and like they will cluster and take from each cluster they will take the uncertainty highest uncertainty score, but like they will cluster by gradient, by its embedding, and uh, then take its most on from each cluster they will take most uncertain ones, and their method like if they can use pseudo label as for ensure that diversity, and diversity is much more harder than uncertainty, because uncertainty is what we can see, like we can see model is uncertain, but we can't see it is diverse enough or not if we actually label it. After let's suppose model is predicting all zero, will predicting all zero, model is predicting half of them as one, half of them as zero, but when take label it actually all are zero. So that means there is not diversity enough. So to ensure the diversity, we need some good met, good method, and right now there are multi-modal active learning and multilingual active learning. That should be that is a key, that those are key methods to look up now. Yeah, so these are the some uh, methods for deep active learning. Uh, is there any questions?
Hi, Gyanendra. So, like, we reached the end of the discussion. Hello.
And can, can I can hear you.
Are you able to hear me? So, like, maybe if you are able to hear us, like, one of the question is if you can talk about or if you can tell us about any resource where we can get started with active learning. think we are not able to reach to Gyanendra. Maybe some network
Uh,
issues.
I
Gyanendra, are you able to hear me? Yeah.
uh,
So if you're able to hear us, like any resources or any material or any source from where we can get started with the very basics of deep active learning, maybe any research paper or any blogs that you can suggest.
so in the slides I gave the reference for all the material
Mhm.
these papers. So from that we can give, and
Okay,
any
got it.
blog I will send over.
Okay, okay, sure. So like the links and resources that you share, like we can then share that with the community members moving ahead. So that would be really helpful. And another thing, it's like when we are talking about deep active learning and this token and all those things that you talked about, it's like because you might have worked around this in your research and all those stuffs, do we see a significant increase in the performance, or like does this make the entire process a little bit more optimal or helps us achieve better results in lesser amount of time?
Yeah. So it can't be uh, uh, beat the supervised model. In overtime, it will it will. So in our case, in the supervised model, we'll have the best result. And in active learning, what we want to do, we want to take 1% of the data and we'll try to reach that accuracy. So there are some of the method that reach uh, in the some of the data set that actually reach only using 2% of data. Uh, like there is a data set, news classification data set. In that, one method reach actually same result with only using 2% of data set. So yeah, we can see in and this method is actually helpful in real world scenario, because real world we don't have the data set to experiment on label data set. And in for this case study, for this method we can actually do perform well without having an data set, and it's better than unsupervised, and it's going it will converge to the supervised with less number of data. That will be the name of it.
Got it, got it. So like definitely advantage over the things that we usually use. So like yes, got a good idea about active learning and how to start. Like once we share these resources and your slide with the community members, maybe they can take more knowledge from this and maybe reach out to you at a later point of time in case they have any doubts moving ahead. So it's like we will put the LinkedIn link of Gyanendra. So Gyanendra, thank you so much for joining us on a 39th meetup, uh, and we really wish you all the best for your future around data science, machine learning, and looking forward to host you again.